Hey guys, welcome to AlgoYogi, and the next problem we're going to solve is same tree. So let's go to the problem. And the description says, given the roots of two binary trees, P and Q, which are the root of the P tree and the Q tree, write a function to check if they are the same or not. And by same, two binary tree being same, we mean they're considered same if they are structurally identical and the node have the same value. So basically their values need to match. In the first example, if we see, let me switch the view here to our iPad. Okay, so here, if you see, the answer for first example is true. And the reason it's true is this is P and this is Q. Here, if you see the left child and the left child of Q, they're both same, given in value and also the structure. And by structure, we mean their left and right child also should be identical to the left and right child of Q as well. So here, we don't have to go like really deep. We just have to look here. If this is the root and this is the root, their values are equal and their left and right side are also equal, which they are in this case. And what would be the case where we return false is if we had a P tree like this and Q tree like this. Let me just take some good example here and use the good combination. 3, 4, 4 and 3. These are not equal. These are not equal. These are equal. So how are we going to solve it? We can use any traversal method, but at every point, what we are really trying to check is if their values are equal and left of P and left of Q, they're also equal, and right of P and right of Q, they're also equal. So recursively, that's the entire algorithm. So if we want to implement it, this is the way we're going to do it. And for all these problems, we're writing the recursive solution, but please know, using the stack, the iterative solution also exists that you can simply write using the stack and while loop. Okay, let's switch the view, zoom. So for recursive function, let's have a base condition, which is if they're both empty, that means we have to return true. So if P is none and Q is none, that means we have to return true. That means they're equal if they're both empty trees. If P is none or Q is none, that means what? The first condition didn't meet, and that's why either one of them is non-empty. That means they're not equal. So we just return false. What's the last condition? We just want to check their values. Return if P dot val equals to Q dot val, and the left subtree is equal to the left of P and left of Q. They are also equal. So first is P dot left. We're gonna check is the same tree. The left of P and left of Q. This is also true, and it's true for the right side as well, the right subtree. The right subtree. Okay, and then what? This is it. In order to call the function, we have to use self because it's part of the class solution. So otherwise, we could call it if it was an independent function. So okay, let's zoom out and try to submit our answer, and yes, it's accepted. What will be the time complexity? That will be big of n. We are visiting, or we could say if all nodes they have to be same, then we could say 2n, but 2n becomes n, right? And space complexity would be big of h, where h is the height of that tree. Okay, so let's go back to our AlgoYogi, mark this problem solved, and see you in the next problem, which is subtree of another tree. Okay, bye bye.